What if a child's future can be flagged by a pencil stroke before reading scores collapse? In medicine, early screening changes outcomes. This new research suggests handwriting may reveal hidden learning disorders sooner than we thought. A University at Buffalo-led team says artificial intelligence may help spot dyslexia and dysgraphia in young children through handwriting analysis alone. That matters because these conditions are often missed early. By the time school struggles become obvious, confidence, reading growth, and classroom participation may already be slipping. The study was published in SN Computer Science. It comes from researchers tied to Buffalo and partners working in literacy, handwriting, and education technology. Their goal is not to replace specialists. It is to build a faster screening layer that helps schools notice risk earlier, especially where expert access is limited. Dyslexia is usually linked to reading. Dysgraphia is linked to writing. But in real classrooms, the signs can overlap and blur. A child may spell poorly, reverse letters, write slowly, or struggle to organize ideas on paper. Those clues can point in different directions. According to federal child health guidance, problems with reading and writing can appear alongside poor memory, trouble paying attention, difficulty following directions, and very poor handwriting that does not fade with time. That same guidance also warns that occasional struggles are not enough by themselves. Patterns matter, persistence matters, and context matters. The challenge is scale. Good screening takes time, trained professionals, and repeated observation across tasks, settings, and developmental stages. That is why this idea is getting attention. It tries to turn ordinary school writing into an early warning signal. The Buffalo Group built on decades of handwriting recognition research. The same broader field once helped automate mail sorting and document reading. University at Buffalo itself points to that history, noting that earlier handwriting recognition advances transformed postal processing before being redirected toward children's learning and communication challenges. Now the target is children's writing. The system looks at how writing happens, not just what ends up on the page. On paper and tablets, models can examine pressure, speed, pauses, spacing, and pen movement. In the Springer paper, the authors frame this as a way to capture behavioral indicators that human screeners already watch for, including handwriting formation, size, neatness, and speed, then connect those observations to AI-assisted analysis. The system can also convert handwriting into text. Then it can look for spelling errors, reversals, grammar problems, and unusual word choices. The Buffalo team says the larger aim is to simplify screening work for speech-language pathologists, occupational therapists, and both general and special educators, rather than asking them to start from scratch. Think of it like a mechanic listening to an engine. The final sound matters, but the tiny vibrations tell the deeper story. The team worked with teachers, speech-language pathologists, and occupational therapists. That step matters because classroom tools fail when they ignore real workflow. They also partnered with literacy expert Abby Olszewski, who helped develop a checklist called the Dysgraphia and Dyslexia Behavioral Indicator Checklist. That checklist tracks 17 behaviors before, during, and after writing. The researchers want the AI system to learn those patterns. They collected anonymized writing samples from kindergarten through 5th grade students in Reno using both paper and tablet-based tasks. According to the University at Buffalo release, the work is connected to the National AI Institute for Exceptional Education, a UB-led research effort focused on AI systems that identify and assist young children with speech and language processing disorders. That helps explain why the project is designed around real school use instead of a lab-only demo. According to the journal paper, the dataset will help validate the checklist, train models, and compare machine screening against human administration. The paper also stresses a practical problem behind the project. Many practitioners have limited time and uneven access to specialized expertise, especially in underserved settings. There is an important caution here. This is an early screening framework, not a diagnosis, and the work is still ongoing. That distinction is critical. A screening tool can raise concern, but diagnosis still needs specialists, fuller testing, and context from the child's development. Major child health guidance also notes that poor handwriting alone does not prove a learning disorder, and that common signs are meant for information, not standalone screening. Still, if this works well, the payoff could be huge. Schools could identify risk faster, start referrals sooner, and reduce delays for families. In underserved areas, that could be the real breakthrough. Not flashy AI, but earlier support before frustration hardens into failure. A child's handwriting may be more than messy or neat. It may be a quiet biometric signal of how language and movement are developing. And if artificial intelligence can help catch that signal earlier, the biggest win will not be the technology. It will be the child reached in time.